In Chapter 4, you're going to be working with matrices, and matrices can be used to transform figures. They can also be used to code and decode messages. They can be used for many real-life applications. So let's first define what a matrix is. It is a rectangular array of numbers enclosed in brackets. Now the brackets are going to look like this. And just make sure you use those when you're working with matrices. Symbols are very important in math. We're going to talk about the dimensions of a matrix. A matrix with 2 rows and 2 columns has, well, let's make that 3 columns. That would be a little bit better because you might confuse the two. So 2 rows and 3 columns has dimensions 2 by 3, and it is red. That's how you read it, 2 by 3. Now each item in the matrix is called an entry. It is a value in a matrix. Now, we're going to talk about address. You have an address where you have a house number in a street, and it gives you the location of where you live in Swartz Creek. And the location of an entry in a matrix is expressed by using the lowercase matrix letter with the rows and columns as subscripts. So here's an example. If we had a matrix B and we wanted to identify an entry, one possible address could be B12. Now over to the side, I just want to make sure everybody understands that rows go left to right and columns go up and down. One other thing that we're going to do today is a scalar multiple, and that is a number that is multiplied by a matrix. Okay, so let's get started. The first thing we're going to do is just to display data in matrix form. And to do that, we're going to get rid of all the words, all the titles, and we're only going to write the numbers in. So we're going to go 0.48, 0.72, 0.005, 0.0075, 0.0075, and 0.01125. And then again, remember to put your brackets in to indicate that it's a matrix. And these actually should be a little more horizontal than what I have them. Okay, we're going to list the matrices. So remember, it's rows by columns. So we have 1, 2, 3 rows, and we have 2 columns. So this is going to be called a 3 by 2 matrix. If we want to find an entry, we need to look at the address. This is a lowercase c, so that means I go to the matrix that has a capital letter C. Now I could have several different matrices. I just have one here for you. So this is the matrix we go to. We want to go to row 3, so 1, 2, 3, and we want to go to column 2. First column, second column. So that would put us right here. So 0.01125 is at entry 3, 2. All right, now we want to, this was the address for this entry. Now we have an entry and we want to find the address. Well, this one actually is in 2 different places. So we have 0.0075, we have one here, and we have one here. So we first identify what matrix it's from, and that's the lowercase letter. And we're in row 1, 2, 3, and this is the first column. So row 3, column 1 is one of the entries. And then also we're in row 2, column 2. So it would be C22. All right, we're moving on to adding and subtracting matrices, and it's very easy to do. Matrices may only be added or subtracted only if they have the same dimensions. So here you have a couple of examples of matrices that can be added together. This is a 2 by 2. This is a 2 by 2, exactly the same, so we can add them. This one is 3 rows by 1 column, and this also is 3 rows by 1 column, exactly the same, so we can add those together. If they have different dimensions, so for instance, this is a 1 by 2, and this is a 2 by 1, 2 rows, 1 column, cannot be added together. These dimensions have to be identical. All right, let's do a couple of examples of matrix addition. And the first thing I'm going to have you do is to write down the dimensions of each matrix, because we're not always able to add two matrices. This one is a 3 rows and 2 columns. This one is 2 rows and 3 columns. This one is 3 rows and 2 columns. And this one is 2 rows and 3 columns. Okay, so let's look at A and C. A is a 3 by 2. C is a 3 by 2. So that means we can add them, and very easy to add. All we do is we add whatever's in row 1, column 1 with row 1, column 1 of the second matrix. So we take 4 and add it to 3. That's going to give us 7. Second one in the first row, second one in the first row. So that's going to give us 0. Then we're going to do negative 3 and 0, and 10 and negative 9. 2 gets added to negative 5, and 6 gets added to 14. So our matrix in row 1 is going to be 7, 0, row 2, negative 3, 1, row 3, negative 3, 20. And again, make sure that you have your brackets. Okay, now we're going to check A and C. A is a 3 by 2, or A and B, sorry. A is a 3 by 2, B is a 2 by 3, so that is not possible. The next one we're going to do is D minus B. In order matters, so I have to take D first and then B. D is a 2 by 3, B is a 2 by 3. Now there's a couple of different ways you can do this. You can write down the matrix D, so 0, 1, negative 3, 3, 0, 10, and then you can subtract B, or whenever you're subtracting, you can take the opposite of everything and add. So that's what I'm going to do. I'm going to take the opposite of everything inside here, make that a negative 4, make that a positive 1, make this a positive 5. This is a negative 3, that's a negative 2, and that's a positive 8. Oh, not positive, sorry, negative. So this should be negative, positive, positive, negative, negative, positive. Or negative, negative, negative. Goodness. Okay. Now we can add those together. So when we add, we're adding corresponding entries. So this is going to be negative 4, 2, 2. This is going to be 0, negative 2, 2. And then we put our brackets. So we have negative 4, 2, 2. We have 0, negative 2, 2. All right, so that is adding and subtracting. And now we're going to use a scalar multiple along with adding and subtracting. And we're going to do the same thing here. We're going to put the dimensions. This is a 2 by 2. This is a 2 by 3. This is a 2 by 2. And this is 1 row by 3 columns, so 1 by 3. All right. We want to multiply matrix A by 2, so every entry by 2, and subtract 3 times matrix B. Well, if I look at my dimensions here, this is a 2 by 2, this is a 2 by 3. That's not possible. Okay, now we're going to try 2 times A minus 3 times C. 2 by 2, 2 by 2, we can do that. So the first thing I'm going to do is I'm going to take every entry in matrix A and I'm going to multiply it by 2. So here's my matrix 2A. That's going to be 8, negative 4, negative 6, and 20. Okay, now I'm going to multiply every entry in matrix C by negative 3, and then I can just add them together. So negative 3 is going to give me negative 9. That's going to give me negative 6. That's going to give me 0. And that's going to give me 27. Now I can add the entries together. So this is going to be negative 1. That's going to give me negative 10. These two entries added together will give me negative 6. These two entries will give me 47. And then I put my brackets around. Okay, you have a few you try it questions to do.